Yes, sir.
Okay, great. So this is actually like yesterday I showed you Jupyter notebook. This is the equivalent of Jupyter notebook. This is Jupyter Lab. Okay, and this has a similar kind of functionality. It's just that Jupyter notebook is built using Python and Jupyter Lab is built using JavaScript. And this is more latest, and this has many other features which we will explore while going forward. Okay. So
So,
you can see here Python. So we can have a notebook of Python. We can also access the console of Python. So both things are possible. Let's go with the notebook. Okay. So this is same like we were working with Jupyter notebook. Okay.
mm,
So what you can do is to follow along. I will be sharing these notebooks
mm.
for with you, so you can install Jupyter at your end. So it is very simple. You can. Are you aware about pip and all those things?
Yes, sir. A
Okay.
little.
Fine. So in your first you install Python. Okay, so that would be the first step. Install Python
Mm,
in your laptop, and then you just do pip install Jupyter, Jupyter or Jupyter Lab, whichever you are comfortable with.
mm.
Okay, so you can follow along this tutorial, whatever they are doing, and just by running this command Jupyter Notebook, you will have this kind of interface available.
Yes.
Okay.
Mm,
So let's import NumPy as NP. So this is an alias that I'm using
mm,
for NumPy library, so that every time I don't have to write, the entire NumPy. I just use NP as a shorthand.
mm,
And so NumPy is basically stands for numerical Python. Okay. So
mm.
all it was built keeping in context that if some numerical computations have to be done in Python, so we should have a package which is easy to do some computations and all those things.
Mm.
Okay.
So your
And
voice is somewhat low.
okay, voice is low now.
Mm.
Now is it better?
Yes, sir.
Okay. Okay. So yeah, so I was saying that this was built in keeping in mind that some mathematical operations that have to be done in Python and all those things.
Mm,
You're using some multi-dimensional data set. So for that, this numerical Python library has been specifically built.
mm.
Okay, just give me a second. I'll change my headphones. Okay, so then the voice will be even more clear. Just give me a second.
Okay.
So this is how we import NumPy, and we use this alias np, and we have NumPy already installed and all those things. Now everything that we use in NumPy, that is actually a n dimensional array. Okay, like you would have studied array in Java. So what were the properties of array, if I ask you?
Homogeneous,
That's right. So similarly, so this
fixed
is very
size. Mm,
very nice. So this is very important that the array is homogeneous. Similarly, in NumPy, whenever we create an array, it should be homogeneous. Okay. So let's try to create an array. Okay. So this you understand. This is a list in Python. This these brackets and some elements. Yeah, this is a list.
mm.
Fine.
Yes.
Now what you can do is we can, if you see the type of this, so type basically is used to check the what is the type
Data
of
type.
this data structure. Fine. So we can now what we'll do is np.array and 1 2 3 4. Sorry, this is np. Now if I see the type, what is it? numpy.nd array. N dimensional array. This can be 1 dimensions, 2 dimensions, 100 dimensions, 200 dimensions. Okay, any number of dimensions. So that's why this is nd array.
Okay.
So now let's see in list, this is also possible. Is this possible or this would give an error?
Possible, sir. It's heterogeneous.
Fine. Now let's do convert this into a numpy array. Okay. So now you see numpy array has this has worked, but the data type that you see that it has already taken something as less than U11.
Means.
So I'll go to data types. This is actually unsigned, kind of thing, but it is, if you see everything, what it has done is, let's store this somewhere. ARR, okay, ARR 0. You see, type of this is what? String. So inherently, what it did is, these were actually integers,
Mm.
but what was the property of the array? That it is homogeneous.
Mm.
Inherently, it tried to typecast all the elements
Okay.
into string.
Mm.
So you see one, you see two. Make sense?
Yes.
So this is the property of, whenever even a heterogeneous list, if we are using in NumPy. So
Mm.
what happens is actually, because NumPy arrays are only supporting homogeneous data types. So
Mm.
that's why they inherently typecast that whatever
Okay.
is the integers. Okay. If here we were using float, let's say, then you see it becomes float. Now you would say, why not integer? Why float? Yeah,
Higher data.
sorry.
Higher data types will
That's
convert.
very nice. So the higher the data type, by higher we mean the more the storage that it is taking into the memory. It is, typecasting to that. Okay, one was explicit typecasting that you would have done in Java, and one is implicit typecasting. So this is implicit typecasting.
Yes.
So automatically it is doing, we don't have to do, some casting and all those things. So this is one very important property that, many people might, who are even using NumPy, they might, ignore, because this is very basics of NumPy. Okay,
Okay, sir.
very nice. Now certain more properties, what you can do is, now let's talk about explicit typecasting. Let's say you are creating an array 1 2 3 4, and you can also provide the d type. D type is what? Data type.
Mm.
I am providing it as, let's say, int, and ARR is what? It is having integers. Fine. Now what I could also do is, you see, here I started doing explicit typecasting.
Mm.
Now I am converting this list, which is having integers,
Mm.
into each of them into a string.
Yes.
If this would have been like this, now what would happen if I do like this?
It will take ASCII value.
So what, ASCII value, yeah, that is correct, but that used to happen in Java or C or C++.
Mm.
But here Python won't understand, and there's no concept of, converting this into an ASCII value directly.
Mm. Mm.
But if I would have used, let's say, instead of this I would have used 10, then this would have understood.
Mm.
So here it won't convert any, alphabet or any character which is
Mm.
not numerical into its equivalent integer using ASCII value or not. Okay.
Okay, sir.
So this is one thing that you would remember in any case. If even if you do str of, not str, because then str is possible of anything. But let's say you are doing an integer of string 1, but if you are doing an integer of string a,
Mm.
this would always give an error in Python, because there is no way for Python, which, in Java and C and C++, on the base they had built, conversion of characters to ASCII values, but here there is no way.
Okay, sir.
Okay. Or so here, any doubt?
No, sir.
I'm also, trying to explain you side by side the difference, what's happening with C and all those things. And
Mm.
if you want to, let's say, uh, you know, uh, convert uh, uh, to ASCII value, so you can use this function. So whenever
Mm.
you want to, know about any function, just put a question mark before that. This is
Mm.
ordinal value, ORD.
Mm.
What it does is it returns the Unicode of the one character string. So now what I can do is ORD of A. What is that? 97.
97.
And
Yes.
this, if I convert into string, this would be converted. Oh, sorry,
Mm.
into integer. Even if I don't convert, if you will see the type, this is already integer.
Integer. Mm.
Makes sense? So you use this ORD, ordinal function,
Okay.
if you want to convert any single character. Now, this is not limited just to A and all those things. You can even do this. It would give you this value.
Plus.
Any ASCII code that's being used on the internet.
Okay.
So this is basically Unicode. So internet usually works on Unicode,
Mm.
and ASCII is a subset.
Yes, sir.
Fine, makes
Yes,
sense.
sir. Yes, sir.
Okay, great. Now let's go ahead with our NumPy example. I showed you that we can do explicit typecasting also. We can convert these arrays into integers or string or whatever we want. Okay.
Mm.
Now this is all this ARR which we were building as of now. All this is what currently one-dimensional array.
Mm.
Fine. Okay. Let me using in this Jupyter notebook there is one very nice feature. If you do press, so what I'm doing is here, if I am inside this cell,
Mm.
if I press escape,
Mm.
okay, this, see, it comes out of shell. Now, actually, after pressing escape, I am in command mode.
Mm.
Okay, what happens in command mode? Let's say if I'm in command mode, if I press A, so it will
Mm.
automatically add a cell before this.
Mm.
If I press B, so again one cell gets added. If I press M, so this gets converted into markdown. So you can do this yourself also. What you can do is, see, this is the way to add a cell before this. If let's say you want to add something here, okay, so you can do like this. You can convert this into a markdown. By markdown, what you can do, you can add things like this, numpy basics, just like you do comments in your code.
Mm.
This is more of comments, but these follow a, the number of hashes denote how big this would be. So this is markdown language.
Mhm.
Okay, so numpy
Yes.
basics. Now let's go into numpy operations. Fine.
Mm.
So let's just make it a bigger one so that it's easily visible. Fine. Yeah,
Mm.
this makes sense. Even you can, using this feature, this is table of contents. You can skip to different parts.
Mm.
This is very handy when you are having, very large notebooks and all those things.
Yes.
Now let's see what all we can do with array.
Hello.
So yeah, am I audible? What I did is this ARR array I've created. Now what I'm doing is ARR dot, and here you see there are many operations that are possible. Fine.
Mm.
You see there are many things that I can do with this
Mm.
array. Okay.
Mm.
Now let's see what all things we can try. Make sense?
Sir, I'm not having.
Sorry, you are not.
I think it's a screen is freezed for some.
Now is it visible? This ARR I have
Yes.
written.
Yes, sir.
Okay, good. So what I'll do is we have created this array. Let's
Mm.
try to do some indexing. Okay, let's see
Mm.
how indexing works. So this is
Mm.
so simple. You use ARR0, and it starts with 0, or ARR5. 5 is not present because we have 0 to 4.
Mm.
Make sense?
Mm.
Now let's say what would ARR minus 1 mean?
Last
And so it starts
error.
from the end.
Mm.
Very good. Now if we take ARR, let's say 1, and we put a colon and we put 2, what
Mm.
would this be?
From 2 and 3.
Makes sense. Last one it won't include every time.
Yes. 2.
So from 1 it will start, and this one it will omit.
Mm.
Okay, let's take till 3. So only 2 and 3 are there.
Mm.
Okay.
Yes.
Great. So this is array slicing. Okay, you can also do, let's say you start with 3 and you go till -1.
Hmm.
Now what would be the output?
So I think two, four, four, four. That's it.
Very good. Okay, now let's see another one. You start with 1, you go till -1, and we put a 2 here. Now what would happen? Let's just see also ARR ones. Yeah. Now what would happen?
Don't know, sir.
Sorry?
And don't know.
Okay. So this 2 is actually meaning, I'll first show you. This will skip, go from start from 2. So 1 means 2. Then it will go 2 spaces. So it will skip 1. Okay. So in
Okay.
2 interval, it will start going.
Hmm.
Let's say I create a very large table. ARR is equal to NP dot. Let's say I create a range 100. Fine. If you see ARR, let's say 10. So this is this. And you can also see length of ARR. See, 100 elements are there. Now I want to go from, let's say, fifth element to 100th element, and I want to skip 5 5. Okay, take the step of 5 5. So it will
Hmm.
start from 4, and then it will go to 1 2 3 4 5 9. Then
Hmm.
again 1 2 3 4 5. Okay, I gave 5 here, sorry.
It should start on four, right?
0 1 2 3
Three,
4
two.
5. Here I'm not
It's
starting
this.
from 1. Okay,
Ah,
here I'm
yes,
starting
sir.
from 0.
Yes, sir. Yes. From
Make
five.
sense?
Hmm. Yes. Difference. We put that.
Yeah. So now every 5 10 15 15, or if you would have done this like 10, oh sorry, if you would have done that 10, so simply like this. Now in Java, how would you reverse an array?
By for loop or by using sort method.
Now see, here what we can do is we can start from -1 and we can go till 0, and we can take the step of -1.
Hmm.
See,
Yes, sir.
this is cool.
Yes, sir.
So this is very simple way. You can even go reverse steps by
Hmm.
doing this, changing this step count. So this is known as step count.
Step count.
Okay.
It is. Is it necessary here, sir, for reversing?
Sorry.
That difference -1, is it necessary?
Yeah, because then only na you are starting from 99,
Okay.
and you are by
Default, it will be +1 itself.
default this is +1, because you see here we are not providing anything, but
Hmm.
it's going one by one.
Okay, sir.
So by default it is +1.
Okay, sir.
But when we are doing it -1, if I'll do this, like this. So what would happen? Nothing is, because from last it is starting and it is
Hmm.
going till 0,
Hmm.
but
Yes,
it
sir.
is going, the step count is not defined. So how will it go till 0? It can
Okay,
only
sir.
go +1 +1 +1.
Okay, sir.
Make sense?
Yes, sir.
This is use of step count. You can also change this. This can be 5 also. This can be 4 also. Anything. Fine? Make sense?
Sir.
Okay. This should be good. Now we are also done with Python slicing. So this is how we can slice any array, NumPy array. Okay. So this is, let's put a subheading here. I'll convert this to markdown, and this is slicing. Okay, you see now inside NumPy operations we have slicing. Okay, so this is the first thing. Now what you can do is, let's go to, um, we can also do, if now let's go to multiple dimensions first to understand our next concept.
Okay.
Let's go to multiple dimensions. Multiple dimensions. Let's create an ARR np dot array, and now we have 1 2, we have 3 4, we have 5 6. Okay, you see this?
Yes, sir.
Now this is what? A
Dimensional.
multi-dimensional array. If you see, I think sizes should also be there. Size is 6. What we can do is, let's try, yeah, this one, and size is 6. Shape, yeah. So now you see the shape is also available. The shape
Yes, sir.
shape was earlier also available, but earlier the shape was what? I'll show you once earlier shape also. Let's go to this one. Yeah, let's go to this one and let's see the array dot shape. So this is what? 5 means 5
Mm,
what?
nothing.
5 comma
Zero.
0,
Mm,
or you can say by default this is 1. So means
mm,
there are 5 columns, but there is only 1 row. Now
mm,
what we have, oh, sorry, this is 5 rows and we have no columns. So this is
mm,
just one dimensional. For one dimensional, you don't get, this second argument. So this means this is one dimensional. But when you move from one to multiple dimensions, you
mm,
see now this has been converted into 3 comma 2. So 3 rows and 2 columns.
yes.
So you see we have provided first row, second row, and third row, and there are 2 columns in each of them. Let's say if I would have done like this, 1 to 10, 20, and 30. Now how many rows and how many columns?
Three rows, three columns.
Very good. 3 rows and 3
Three
columns.
columns.
So this is how we can make multiple dimension. And inside this also what we can do. Yeah, I'll show you one thing. And let's say 9 and 10. Let's say 19 and 20. Let's say 29 and 30. Now what it's saying is, you read this word,
Inhomogeneous.
what happens
Array.
is,
Array
that's
is
right. So one is
infinite.
integer, second is integer. This is what?
List.
List. So all these rows should be individually, they should be having same data type. So if we do like this, this should be possible. Why? If I do like this, I'll show you one thing. Let's say I do like this. Okay, I convert this into string. Now what would happen?
Everything will be converted to string itself.
Fine. But when we have a list, the issue is that how will it convert these into a list?
Yes.
Okay, so that is the issue that it is facing. Make sense?
Yes.
Fine. Let's just remove these for now. Let's go to 2 dimensions. Okay, now we have a 3 by 4 array. Okay, again the slicing is again similar. You see this is row. You see the 0th row we have got, and this is the column. 0th row, first column, 0, 1. Make sense?
Yes, sir.
Now more advanced, 0, 2, 2. So 2 rows and let's say 2 columns. This is giving what? Hmm. This would be like this.
Event words.
Yeah. Now this makes sense. Now you see what I am doing is, this is a bit complicated.
Mm,
Just let me know if you don't understand.
mm,
What I did is, from this 3 by 4 array,
mm.
I took a sub array. So you see I'm taking a sub array. Now what is the shape of this array? 2 by 4. From this 3 by 4 I went to 2 by 4. Okay. So I took 2 rows from the 3 rows. Now this is again a 2 dimensional array.
When what's 0 is 2?
0 is 0th row. Like we
Mm.
used to, go from different, let's say this was the array. If we have to
Mm.
go from 0 to 5, so what we do is 0 here, then colon, and then 6.
Mm.
We used to do like this.
Yes.
Similarly here, what we'll do is now we have moved to multiple dimensions. Now this first, first this bracket, square bracket, whatever you are providing here, this is the index of
0th row.
row.
Mm.
Index of row. Okay,
Mm. Mm.
0th row, first row, second row.
Okay.
Make sense?
Yes.
Now if I want to get a multiple rows, let's say I want to get 0 to 2, means 0th row and first row, both I want to get. So using this, what I can do is I can get 2 rows.
Mm.
Make sense?
Yes.
Now this is again a two-dimensional array
Mm.
that is returned. Now if I want to get the element 4 from here, how will we get?
A of array of
So we,
1 comma 1
what is the row?
comma.
What is the row? First find the row between these two.
It's a first
Row
row,
is
and
first, and what is the column?
second first column.
So we get 4. Make
Mm.
sense?
Yes.
Let's say if I want to get 29 from this ARR, how can I do that? ARR, then
Oh, 2 comma 3. 2 comma.
fine.
Yes.
Very good. So we can also slice, multiple dimensions from multiple dimensions, and we can also slice the exact values.
How to get
Okay.
only one single column?
One single column you want to get?
Mm.
Which column? Let's discuss that. Which column you want to get?
First column 1, 3, 5.
135 you want to get.
Mm.
So for 135, the issue would be, let's say you want to get 0th row. So now it has extracted the 0th row. Okay. Now if you see, you just have the 0th row. So simply using, the slicing thing, or what you can do is I'll show you one more method of slicing. Let's get all the rows, and let's get the first column. Sorry, 0th column, 135.
Okay.
Fine. Now this is another way to slice. Okay, we can also use comma. Now the first argument would be what? The row. First arg is row, second arg is column.
Column.
Fine. You can also take multiple, and this simply colon means that you are giving it all the rows.
Okay.
Instead of column, you could have also done like this: 0 colon 2, so means 0 1 and 0 column 3 and 0th column. So this would also give the same result. But if I just put a colon here, this means all the values. Make sense? This makes sense.
Yes, sir.
Even let's say if I would have done like this: 1 2 3 4 5. Okay, ARR is this, and even here if I put like this, it will give me all the results, even in one dimension.
Yes.
Fine.
Yes.
Let's comment this out and put it here just for reference. Gives all the values. Fine. Very good. Now we have also understood. Okay, we can also do like this. Let's say 0th row and 1 2 3 or 1 to 2. Oh, sorry, the array has changed. Let's create the array again. This is the array, and 1 2 3 0 to 2. So now you see From multi-dimensional array, you can, from a 2D array, you can also extract a 2D array using this method. What I did is I've specified the rows. So I want the 0th row and the first row. So I got the 0th row and the first row, and from within that row I just want the first and second column. So only this much: 0th row, first row, and first and second column, only this much. 2, 4, 9, 19.
Yes,
If
sir.
you had to do this in Java, you had to, iterate over the array and do all those indexing and all those things.
Yes.
When I is this, j is this, then only extract. But in NumPy, you see, you can directly do such things using this method.
Yes, sir.
Make sense?
Yes, sir.
Okay, very good. Any doubts still here?
No, sir.
Very good. Now, what else we can do is I'll show you one more property. Let's take, okay, let's take Boolean indexing now. Let's say ARR is np.array. This property would be helpful in pandas also. In pandas also we'll use this property. Okay, this is the ARR. Let's do just a true. Okay, what happens? We get everything. If we do a false, we get nothing. Okay, so this is known as Boolean indexing.
Means.
Means if you give a true, it will give you this. Or what I could also do is, just a second. Let's see. Okay, let's not confuse it here. Let's take it like this. Okay, true, false, true, false, true. Now see, what I provided as an index is another array which has just Boolean values, true and false. And for whatever values I have true, those elements would be returned. You see, 0th was true, so you got 1. This was false, so you didn't got 2. This was true, so you got 3. This was false, so you didn't got 4. This was true, so you got 5. But this itself is an array. Okay. Here I'm just providing simply true and false. If I provide false, nothing would be returned. If I provide true, everything would be returned. But if I use a list and provide true and false here, then I can, you just using true and false, I can return values. Make sense?
This last one I haven't got.
No worries, no worries. Let's say from this 1, 2, 3, 4, 5, okay, you just want to return 3 and 4. Okay, one way was you can do a simple slicing.
Yes.
You could do slicing, but
Yes,
what
sir.
I'm saying is you can also, let's make this a bit simple. Boolean, let's say this is Boolean array, and inside this Boolean array, whatever you are, so how many elements are there? 5 elements are there. So 5 true and false you will provide, and for whichever position you will write true, that element would be returned. See, for this and this I had written true, and I pass this array into this as an index to this ARR. So only the ones which were true, those got returned.
Yes, sir.
Make sense? Now why this is useful, I'll show you. Let's say I do ARR and I do ARR is less greater than 3. Now see, what it did is it went through like we do loops in Java. So it is doing that loop automatically. So for every element of ARR, it is automatically checking if that element is greater than 3 or not. If it is greater than 3 means true, it would return you those elements. If it was not greater than 3 means false, then it would not return those elements.
Okay,
So
sir.
you see, this is very powerful.
Okay, sir.
Let's say I had an array np.array, the np. Let's say a range. So a range is simply, return evenly spaced values within a given interval. You just give a start and stop. By default, start is 0. Let's say you want between 0 and 100. You want evenly, even number of elements. So from 0 to 99. So you can just use this a range function.
Okay.
Fine.
Okay, sir.
So now I want all the elements from ARR that are divisible by 5.
Mm.
Mod 5 is, so what it would do is it would check for mod 5 is equal to 0.
Mm.
Okay, if the
Mm.
mod 5 is 0 means that number is divisible by 5.
Mm.
Make sense?
Yes, sir.
See the table of 5.
Yes, sir.
See why Python is so powerful.
Yes, sir.
Very nice. So this is how we can simply using any boolean condition, anything you can provide,
Ah.
and you can simply filter your array. So this is one way to filter or slice your array. Let's just save this. Numpy basics. Make sense?
Yes, sir.
Very good. Now what next we can try to do is, next we can go into iterating over the array. Okay, let's also see what is the best way to iterate over some array. If you are doing, if you are simply working with any array, so you can also do iterating over the array. So that is very usually very simple, so you can easily do that and all those things. But still I'll just show you. So let's say you have item in, just a second, I'll just respond to a message. Meet, yeah, let's say for item in, so you are aware about the for syntax of Python.
Yes, sir.
Great. So let's say for item in ARR, and let's say we just print item. So simply it will print the item. Okay. Or we
Mm.
can do something advanced also. If item mod 7 is equal to 0, then only print the item. So it can also print the item. So simply
Mm.
you can do for item in ARR, then you can simply, this would go through, item would become every element that is inside this numpy array. Okay, and if you see
Okay.
the type of item, you see this is a single instance of the numpy.int32. Okay,
Means
so
it's in
this,
32.
sorry,
It's a numpy in 32 means.
numpy.int32 is actually a data type. Basically in, you know uh, like in object oriented programming, you create an object of a class. Similarly,
Mm.
numpy.int32 is a class in Python,
Mm.
and this 0 or 7 or 14, these are actually objects.
Values.
Objects, you can say, of those class. So basically inside the object the value has been set 0, inside the object the value has been set 7. Make
Mm.
sense?
Yes, sir.
Great. Like this you can do anything that that is possible inside your for loop. So this is I think very important. Now let's do some simple numpy Okay, we are already inside the operations. We have seen slicing, we have seen Boolean indexing. Now let's see changing shape. Let's say you have this ARR is equal to np dot array and 1 2 3 4 5. Fine, you have this ARR, and what is the shape of ARR? What is the shape?
Shape is only one row.
5 comma nothing, because this is a one dimensional array. Fine. Now what you can also do is you can change the shape of your numpy array. Okay. How you can change, I'll show you. You can use the arr dot reshape function.
Hmm.
Okay. If you just put a question mark, this is np dot reshape would be working. Yeah. Okay. So you see in reshape you can provide your array and you can provide the new shape, and uh, order C is basically using C like indexing or Fortran like indexing. Let's skip this for now, but the default value is C. So now let's say np dot reshape and we provide it arr, and the new shape, let's say we provide it as uh, 2 comma 3. So what happens? One second. This would become 1 comma, because there are how many elements?
5 elements.
5 elements. So the shape for, let's take 6 elements actually. Make this simple. Now this is 6. Now now this would become 2 comma 3.
Hmm.
Now you see 2 rows, 3
Three
columns.
columns.
Fine,
This sir.
because there are 6 elements.
Okay,
Now
sir.
if I had a very large array, let's say arr is equal to np dot a range, and I have 100 kind of thing, and if I do np dot reshape and I provide ARR, and now 100 we can put it in several different ways. Even this we
Hmm.
can put it in several different ways. Let's say 2 comma 3, 3 comma 2, but 3 comma 2 it won't be there because there are 3 rows and 2 columns. This would not happen. One second. 2 comma 3. Oh, it has changed to 100 actually. Yeah, one second. Yeah. So even 3 rows and 2 columns, that is also possible.
Hmm.
Make sense?
Yes, sir.
So let's see what all possibilities are there. 2 rows, 3 columns, 3 rows, 2 columns, then 1 row, 6 columns. Fine.
Hmm.
1 row, 6 columns, 6 rows, 1 column. So you see all the
Yes.
combinations how this can be converted into a two-dimensional array are
Yes, sir.
present here.
Yes, sir.
Fine.
Hmm.
Now same with this 100. Let's say each row has 5 values and there can be 20 such rows. No. 5 into, yeah, this should be, okay, this is 6 only. Just a second. Yeah. So you see 5 rows and 20
Three
columns.
columns. Hmm.
Fine.
Yes,
Or
sir.
we can also do, let's say, let me convert this into different type of array. Just a second. What would be the value? Let me do it in calculator. So let's say we have uh, 5 rows, and so 100, how to divide 100 into, we cannot divide 100 into 3 parts. Let's take anything else. Let's say 120. 120 divided by 3 is 40. So what we can do is, so there would be 40. So, and 40 divided by 2 is, 40 divided by 2 is 20. So
Hmm.
basically 20. So for rows, what, how many rows we have? We have to take 20. Okay, so 20 rows and 20 into 20 into 2 into 3. Now you see, this has now become a three-dimensional array. You see, this would be at very, a bit tough to visualize, because it's easy to visualize in 2 dimensions when working with these screens and all those things. But when we are working with multiple dimensions like 3 dimensions, 4 dimensions, 5 dimensions, numpy can go to any number of dimensions.
So
And
first is 20 rows and
20
two.
rows, 2 columns. And this two-dimensional array, what would happen is, let me draw something for you. Okay, let's see, we have, okay, let us take this. So this means there are 20 rows and 2 columns. Okay, so there are 20 rows and 2 columns. Fine. So this is one two-dimensional array. Okay, so now there are how many of such two-dimensional arrays? 3. So this is one two-dimensional array, there is one more two-dimensional array like this, and there is one more two-dimensional array like this. So these 3 now make a third-dimensional array. So this is 3D. Make sense? So 20 by 2, 20 by 2, 20 by 2, and 3 of these make a three-dimensional numpy array. Yeah, is it making sense? In 1 second, let me show you here. Let me show you any image. I think that would be easier. Yeah, see this. So you see, this is one two-dimensional array of 3 rows and 3 columns. This is another one of 3 rows and 3 columns. This is another one of 3 rows and 3 columns. Now these 3 combined make a, see, this is 2D, this is 2D, this is 2D, but 3 of these now make a third dimension, which is apart from these 2. Now is it making sense? This is 2D. Okay, this is 2D, simply 3 rows and 4 columns. Now when such 2Ds also get combined, many of such 2Ds combine to make a third dimension. Make sense? You can understand it from here also. And the very interesting part is that whenever you are using any machine learning algorithm, whether you use logistic regression, you use random forest, you use XGBoost, which we will study also, every machine learning algorithm takes as input these numpy arrays. Okay? Most of the machine learning algorithms, even the deep learning algorithms, they
Here,
take
what
this.
is 2? So what is meant by 2?
Sorry, what is?
Meant by 2.
2? 2 is 2 columns. Let me show you one example. Let's say you have an array. Let's take a simple one. Array of a range. Let's take np.a range, and let's take 6. Fine. Array is this. Now what we do, np.reshape, and the array is this, and the new shape is what? Let's say 3 by 3. Okay, this would
3,
be 9.
3 by 2.
2. 3 by 2. Let's take 3 by 2. 3 rows and 2 columns. This is one two-dimensional array.
Yes, sir.
Now let's say we had 9. 1, 2, 3, 4, 5, 6. 6 into 3. Now let's say we have 18 elements. Okay. So first we have to convert them into two-dimensional array. Then multiple of those two-dimensional arrays would form a 3D array. So what we will do is np.reshape arr and 3 comma 2. This is the 6 elements. And how many such two-dimensional arrays? 3. So 18 elements. 6 into 3, 18. Now you see, this is one 2D array. This is one 2D array. This is one 2D array. And combined, they form a third dimensional array. Now is it making sense?
Yes, sir.
Great. We can also form this kind of array. If I show you, let's say this is third dimension. This is second dimension. Let's say this is second dimension. Just a second, who's there? Hello.
Yes, sir.
Fine. So now let's say 1, 1, 2, 3. This is one dimensional array. Okay. Let's say this is 2, 3, 4. So now this is two-dimensional array. One two-dimensional array. Okay. Now we can have multiple of these. See? Somewhere it's saying incomplete input. That is in line 15. Okay, np.array ident closed. So this now arr is equal to this, and if we see the arr dot shape, see 3 comma 2 comma 3. So three
Three
rows.
rows, two
You know,
columns,
yeah.
three elements in each row.
1 second, let me check. This should be ideally 3 comma 2 comma 3, or just a second. Just a second. Let's check the shape here. So this is 3 comma 2 comma 3. Fine. So basically three two-dimensional arrays, two rows, and three columns. So we are starting with the number of dimensions. So three two-dimensional arrays, two rows, and three columns.
Mm.
Fine.
Yes, sir.
If this was, yeah, this makes sense. So if we do a 3 here and a 2 here, so now you see three two-dimensional arrays, three rows, and two columns. Fine.
Yes, sir.
Good. So never you will have to, create a three-dimensional array or all of this, but it's very important to, understand that how NumPy is internally working in multiple dimensions. So that I think is very important, so that because every,
So
algorithm is using,
two-dimensional means two cross two, right?
yeah, no, not two cross two. Two dimension means that there are rows and columns. It can be anything cross anything.
Mm.
100 cross 200 also.
Mm.
But that is two dimensions. In three dimensions, when you
Three
go,
cross three means three elements, three elements.
three rows, three columns.
Okay, sir.
Okay, so this is the two-dimensional part, and this is three dimensions. So when if you would have seen any machine learning problem, let's say you want to predict rain today. Okay, you want to predict rain. What all things you will take into account? Let's say temperature,
Mm.
temperature, and what all you will take into precipitation.
Mm.
Fine, temperature, precipitation. So let's say sunrise time, sunset time. Okay,
Mm.
this also you're taking into account. Now this would generate a two-dimensional array basically with how many, let's say you did this, you collected the data for 100 days. Okay, so there would be 100 rows
Mm.
and there would be four columns.
Mm.
Make sense?
Yes, sir.
Great. We'll see these examples also
Mm.
when we are working with, pandas and all those things. Okay, so NumPy, this is also done. This is also done. We have also seen reshaping of NumPy arrays. Now let's move to, you can also, transpose your NumPy arrays. So that's pretty simple. Let's say you create a np.arange. Now I'll combine multiple functions. Okay, now you see, and I also do a reshape. Let's see if 2 comma 3. Now you see I have combined multiple functions. I created a NumPy array of 6 elements, and then I reshaped that into 2 by 3, 2 rows, 3 columns. Is it fine?
Yes, sir.
Great. So this is a shortcut for you. So you don't have to, do everything for every time you save ARR and then you do np.reshape and all those things. You can simply do like this also.
Okay, sir.
Fine.
Yes, sir.
Now this is what 2.3. Now you want to transpose this. So you can use .p. T is for transpose.
Hmm.
So what it would do is this 2.3 would get converted to 3.2. Three
Hmm.
rows, two columns.
Hmm.
Fine. You can do like this. You can
So
either, oh,
think
sorry,
it's
yeah.
freezed. Screen is freezed.
Yeah, is it visible?
Yes, sir.
Fine. Now let's say you have multiple arrays. np dot range, 6 elements. Okay, and you
Hmm.
do a reshape
Hmm.
of, or let's do not do a reshape to start with. Then you have an ARR2 again of 6 elements. Fine. You have
Hmm.
ARR1 and ARR2. Both have same values. Now what
Hmm.
you can do is, let's say you want to create a third array.
Hmm.
Okay,
Hmm.
that is combined of these two. So what you
Hmm.
can do is np dot concatenate, and what you can do is arr1 arr2. You see 0 1 2 3 4 5 0 1 2 3 4 5.
Hmm.
So you created the third array by concatenating these two. Make sense? Concatenating means simply joining.
Okay, sir.
Fine.
Yes, sir.
So you can also join using this, or now this join can be in multiple dimensions. Now here we just did a simple like this. We can also do a stack over this. What I can also do is I'll show you one more thing. Let's just do a concatenate, but now the axis of concatenation is 1. Okay, so because this is 0 dimensions, so this is not allowing. Let's go to multiple dimensions now to understand this. Let's say we do a reshape of this into, we create a 2 by 3. This would be a bit tough to understand, but let's
Again,
try.
it's freezed.
Is it, you see this ARR1, ARR2?
Ah, yes, sir. Now.
Okay, great. So now I want to join this. If I simply do, let's say np dot concatenate, and I do
Yeah.
a, sorry,
Again, freezed.
now also is it freezed?
Uh, well, you are taping. It's. I think it will get freezed.
Is it freezed again?
Now it's visible.
Okay. No worries. Let me close this now. Now it should be fine. Okay. Is it visible now?
Yes, sir.
Fine. So now you see, now I concatenated or joined multiple arrays, multiple dimensional arrays also. So that is also possible. Fine.
Okay, sir.
Now if, and here if I try to do axis is equal to 1, yeah, this is pretty cool. Now let's compare axis. By default, axis is equal to 0. By axis, what I mean, this means if axis is 0, this means you have to concatenate by rows. If axis is equal to 1 means you have to concatenate by columns. By that, what I mean is, again, I'll can draw for you.